Why is the sky blue? Have you ever pondered this question on a sunny day? It's one of those mysteries that often elude us, despite its daily presence in our lives. As children, we might have made up stories about enormous oceans above us, or perhaps a giant invisible bluebird painting the sky each morning. But as we grow older, these fantastical explanations give way to a more scientific curiosity. So, what's the real story? Why does our sky, vast and limitless, cloak itself in this tranquil hue? What cosmic artistry is at play here? The answer lies not in fairy tales or mythology, but in the realm of physics and the wonders of light. It's a tale of wavelengths, atmosphere, and our eyes' perception of the world. So strap on your thinking caps, because we're about to embark on an enlightening journey. Prepare yourself for an enlightening journey as we uncover the truth behind our beautiful blue sky. The answer lies in a phenomenon called Rayleigh scattering. Take a moment and imagine the sun as a colossal disco ball, sending out light in every color of the rainbow. Each of these colors is represented by a different wavelength. Red has the longest wavelength, and violet has the shortest, with blue somewhere in the middle. As this spectrum of sunlight travels through the atmosphere, it collides with molecules of oxygen and nitrogen. This is where the magic of Rayleigh scattering comes into play. Named after the 19th century British physicist Lord Rayleigh, this phenomenon explains how these tiny molecules scatter short wavelength light, such blue and violet light, to the four corners of the sky. Now you might be wondering why it's called scattering. Well, imagine tossing a handful of pebbles into a pond. As they hit the water, they don't just sink straight down, do they? No, they scatter, they bounce off in different directions. It's the same with light. When sunlight hits the molecules in our atmosphere, the short wavelength light is scattered all over the sky. So imagine again those pebbles hitting the pond. The smaller the pebble, the more it's going to bounce around. It's the same with light. The shorter the wavelength, the more it's scattered. And since blue and violet light have shorter wavelengths than colors like red or yellow, they are scattered more. That's why when you're standing on the ground looking up, the sky appears blue instead of a muddy rainbow mess. The blue light has been scattered in all directions, reaching your eyes from all over the sky. But here's the twist. The sky isn't just scattering blue light, it's also scattering violet light, even more so than blue. This might lead you to wonder, if violet light is scattered more than blue light, then why isn't the sky violet? So, the blue light is scattered in all directions, filling the sky with a blue hue. But wait, why don't we see violet then? If blue and violet light waves scatter the most, why isn't our sky violet? That's a fascinating question, isn't it? Well, it all comes down to our eyes and how they perceive light. You see, our eyes are more sensitive to blue light and less sensitive to violet light. So even though violet light is scattered more by the atmosphere, we're just not as good at picking it up. But that's not the whole story. Sunlight also plays a part. When we look up at the sky, we're not seeing pure sunlight, but sunlight that's been scattered across the atmosphere. And while sunlight is made up of many different colors, it reaches us more at the blue part of the spectrum, rather than the violet. This further enhances the blue coloration we see. So it's a combination of the way light scatters and how our eyes perceive light that makes the sky look blue. So, to sum it up, the sky's enchanting blue color is the result of a fascinating dance between sunlight and our atmosphere. It's a performance brought to life by Rayleigh scattering, a process where the shorter blue and violet light waves are scattered in all directions more than the longer waves of red, orange, and yellow. This scattering paints the sky with a blue brush, creating the azure spectacle we see every day. But if violet light is also scattered more, why isn't our sky violet instead of blue? Well, it's our eyes that play the deciding role here. Human eyes are more sensitive to blue light and less sensitive to violet light. Additionally, sunlight reaches our eyes with more blue light than violet, tipping the scales in favor of a blue sky. There you have it! The next time someone asks why the sky is blue, you can share this fascinating scientific explanation with them.